FastMCP3 employs a tool-based abstraction layer to bridge protocol disparities between clients and servers, enabling prompt access through standardized tool calls. This mechanism leverages the PromptsAsTools transform to generate runtime-rooted tools that encapsulate prompt operations, ensuring middleware consistency across the system. The upcoming code demonstrates how a client invokes the getPrompt tool to retrieve a rendered prompt with specified arguments, showcasing the seamless integration of tool calls with prompt rendering functionality. You'll observe the structured request format and the resulting message array response that adheres to MCP standards.
Hash prompt with required and optional arguments. Result equals await client call tool. Get prompt. Name, analyze code. Arguments. Code, x equals 1 / in print x. Language, Python. Response equals JSON. Loads result data. Hash. Hash messages. Hash. Hash role, user. Hash content. Analyze this Python code. \nx equals 1 / in print x. Hash. Hash.
This code demonstrates the PromptsAsTools pattern, which bridges the gap between clients that only support tool calls and servers that expose prompts. The pattern works by generating two tools, listPrompts and getPrompt, that provide indirect access to server-side prompts through a standardized tool interface. Here, the client calls getPrompt with a prompt name, analyze code, and arguments code and language, which the server processes and returns as a rendered message in MCP format. The approach enables prompt access for tool-only clients while maintaining server-side control. By routing through the server's middleware chain, operations like authentication and rate limiting apply uniformly to both direct prompt calls and tool-mediated access. This design avoids duplicating logic, but introduces a slight indirection cost. The trade-off is justified when client capabilities are limited, as it preserves prompt functionality without requiring client-side protocol upgrades. The response format follows MCP's message array convention, ensuring compatibility with downstream consumers. Each message includes role and content fields, supporting multi-turn interactions if needed. The pattern assumes prompts return text-only content, simplifying the interface but requiring binary data to be handled separately. This constraint aligns with typical LLM use cases where text prompts dominate, though it may necessitate additional tooling for mixed content scenarios. Let's break it down.
Result equals await client call tool.
Calls the call tool method on the client object asynchronously using await, storing the returned result in the variable result. The method invocation appears to be incomplete as no arguments are shown, but the line demonstrates an asynchronous remote procedure call or tool execution request that will suspend execution until the operation completes.
Get prompt.
References a string literal getPrompt, which appears to be a key or identifier in a dictionary context, likely used to retrieve or reference a prompt-related value or function.
Name, analyze code.
Defines a dictionary key name with the string value analyze code. This creates a key-value pair where name serves as the identifier and analyze code is the associated value in the dictionary structure.
Code, x equals 1 / in print x.
Assigns the integer value 1 to a variable named x, then outputs the value of x to the console.
Response equals JSON. Loads result data.
Parses the JSON data from result data and stores the resulting Python object in the variable response. The JSON loads function converts a JSON formatted string into a Python dictionary or list, depending on the JSON structure. Here, It processes the data contained in the data attribute of the result object. The PromptsAsTools pattern bridges protocol gaps by exposing server-side prompts as standardized tools, enabling clients with limited tool call support to access prompt functionality. Here, the client invokes getPrompt with a prompt name and arguments, which the server processes through its middleware chain, ensuring consistent authentication, rate limiting, and other operations. The response adheres to MCP's message array format, delivering a rendered prompt in a structured, role-based format compatible with downstream consumers. This design introduces a slight indirection cost, but maintains server-side control while accommodating clients that don't support direct prompt calls. The trade-off is justified when client capabilities are constrained, as it preserves functionality without requiring protocol upgrades. The pattern assumes text-only prompts, simplifying the interface but necessitating separate handling for binary data, a constraint aligned with typical LLM use cases.
The empty arguments whisper to the prompt, and suddenly the code wears their invisible syntax.